Okay, so I just wanted a quick review the layout and format of the master file table, or the MFT. And we're going to right now be focusing on the master file table record header, which is outlined in yellow toward the top of this image. That's actually going to be where a lot of the very important information is for you to start your investigation. So this is the layout. First 4 bytes are FILE. The next 2 bytes are the offset to the update sequence, and this is an offset within the MFT. Next 2 bytes or the next word is the size in words of the update sequence number in the array. Now we have 8 bytes, which equates to a long long. And this is the log file sequence number. Following that is the sequence number and the use and deletion count. Following that is the hard link count. Next comes the offset to the first attribute. A word indicating the flags, and then a D word which contains the real size of the file record. Following D word is the allocated size of the file record. Then comes a long long, which is a file reference to the base file record. The next word is the next attribute ID. The next word aligns records to 4-byte boundary. This is actually just a filler. The next D word is the number of this MFT record. And finally, we have the whole update sequence series. And this is the C code for the MFT header record. And I did show you that in source code in the last video. So this actually equates to the C code that I showed you and actually ran and used. So let's kind of get into some more of the specifics. The MFT record header is 48 bytes in Windows 2000 and 56 bytes in operating systems past Windows XP. So for practical purposes, you might as well just consider 56 bytes because you're rarely going to get anything pre-Windows XP. So what we're going to do now is go through and look at each of the offsets in the table individually. So FILE, this provides an ID or a signature of a file record. The fields that follow, starting at offset 4 and 6, allow finding the update sequence number and array, which reside in the last 2 fields. So the log file sequence number, this is a large number actually, this is changed every time the record is modified. Okay, remember we talked about the log file contains the journaled entries for things that change. So this is actually going to link this file to its entries in the log file. The sequence number, this is the number of times this MFT record has been reused. Okay, the increment is done when the file is deleted. So from a forensic standpoint, that record gives you usable information that may be important for some of your investigations. The hard link count is interesting. We didn't have this concept in FAT. But on NTFS volumes, each file can have multiple hard links. And thus a single file can appear in many directories, or even in the same directory with different names. Now when we get to Linux next semester, we'll also show that Linux can have multiple hard links. Because all of the links reference the same file, it can be accessed by any of the links. That's why we have the amount of current or existing hard links at offset hex 12. This usually should be equal to 1. However, if it is equal to 0, the file has been deleted. A file is deleted from the file system only after all links to it have been deleted. So in other words, if you have 5 hard links to the same file, deleting one of the hard links only deletes that link and won't actually delete the file until all of the hard links have been deleted. So here are the flags that we're going to be talking about. This is offset 16 and 17 hex. Whether the file exists, the flag will be 1. File deleted, flag is 0. Directory exists, flag 3. Directory deleted, flag 2. So once the hard link count is equal to 0, the file deletion happens, and the flags, as described before, once the hard link count is equal to 0, the file deletion happens and the flags are offset, and the flags are changed to 0, marking the file record as available for reuse. There is the possibility that values may differ, especially in the NTFS system files. So let's take a look here. We have values at offset 22 decimal or hex 16. So object ID, quota, and rate parse have values of hex 0D00, and of course if this is byte swap to be 13. A value of 0 indicates it's a USN journal. A value of 0900, which is going to be 9 after it's byte swapped, indicates a secure record. So now let's talk about real and allocated size. The allocated size is how much space the record takes up on the disk. This should be a multiple of the cluster size and should probably be equal to the size of an MFT file record. The real size is a count of how many bytes of the record are actually used. The real size will be padded to an 8-byte boundary. The next attribute ID. This is an ID that will be assigned to the next attribute added to this MFT record. It is incremented each time it is used. Every time the MFT record is reused, this ID is set to 0. And the first instance number is always 0. So the base MFT record is 0 for base MFT records. When it is not 0, it is an MFT reference pointing to the base MFT record to which the record belongs. The base record contains the information about the extension record. This information is stored in an attribute list attribute. Okay, so now let's talk about update sequence number, update sequence array, NTFS fix-up bytes. These sectors allocated to the MFT records are crucial for maintaining the structure. Because a single sector could fail, it's important for NTFS to be able to detect errors in the sector. For this purpose, the sectors have fix-ups, which are kept in an update sequence array. MFT file records use fix-ups to protect data integrity. The header of each of these records contains an update sequence number and an update sequence array. The last 2 bytes of each sector of the record are copied into the update sequence array, and the update sequence number is written in their place. Many important metadata records use fix-up to protect data integrity. File records in the MFT, INDX records in directories and other indexes, RCRD records in the log file, RSTR records in the log file. When the record is read, the update sequence number is read from the header and compared against the last 2 bytes of each sector. If it succeeds, then it copies the bytes in the update sequence array back to their original places. The fix-up bytes are forensically significant. A simple keyword search on the string file in free space can return a hit from previous existing MFT file record. The examiner can filter these hits and examine the byte offsets between consequent hits. Knowing the size of the MFT file record, the examiner can make the determination and examine the hits looking for MFT file record attributes. If the examiner determines that the hit returned an MFT file record, further examination of the values at different offsets can be performed. For example, examination of the flags, which is at hex 16 offset, will tell was the record deleted or not. What I'd like to do now is introduce you to a new tool, and it is Autopsy. So if you go to this link, sourceforge.net projects Autopsy, you'll see a download link for the Autopsy program. And this is an open source forensics program that's actually fairly good. And we're going to kind of go through the basics right now just to get you started. And I just want you to download it, install it, and take a look and kick the tires. Okay, let's go ahead and create a new case. CGS 5131. Case number 2, Rick. Okay, and I have some images, but I'm going to go ahead and use a local disk as I've been doing for a lot of my previous examples. So let's go ahead and open up O, my famous O drive. And we'll go ahead and let it do its thing. Okay. So this is going to be similar to what you see with WinHex. You see these meta files. You see these metadata files. You see a subdirectory that I had created. Here are other metadata files. There's the log file. Master file table. Here's the mirror of the master file table. So forth. And here are the actual files that are listed in the root directory. Okay, and when you click on them, it goes there. And you can see what they look like. And this is actually quite a bit nicer than WinHex because it actually has a viewer. Well, that's not a viewer, but these images, it actually uses a viewer. You can definitely look at the binary of these images, but to me it's really nice to be able to look at the viewer. So if you just click on hex, you'll actually see the actual data. If you click on media, you go back. Another nice thing is strings will actually look for strings within that file. And that's not very important for an image file, but let's say there's an exe or something that you want to take a look at. So it'll find all the strings within an exe, and you might want to end up data carving them or saving them or something. So we're going to actually use this program more and more over this semester. So I just want you to download it and just kind of run through it. Just make sure everything's working right. So the programs you should be getting familiar with now are going to be WinHex and this new Autopsy program, where it's not new, but I'm new to us, new to this course. So you need to make sure you're really familiar with WinHex and Autopsy. And if you have any inclination to programming, I would also suggest you download the source code that I've put onto the web course and try to compile it. Just make sure that you understand what I'm trying to do there. Okay, so just get started with Autopsy. So there is another tool I'd like you to take a look at. However, it's not as comprehensive as WinHex and Autopsy. And I have not spent the time to get to know this, but it's MFT dump. When you type it, At the command prompt, it goes ahead and shows you all the command line parameters you can use. But what I'm doing is I'm looking for a volunteer from class, or a number of volunteers. You can all do this if you want extra credit. I know some of you have asked me for extra credit, but I'd like for someone or some people, however many of you want to go ahead and create a video that first explains what MFT dump is, second explains how to use it, third shows part of the documentation and explains these. For instance, this is the documentation and it's got all this information. We've already talked about this, so you can just basically rely on what I've already talked about as far as the MFT records. But I'd like for someone to create an 8-minute video, and the video would be a combination of PowerPoint slides and, such as I have here, command line examples. So if you can do that, you'll have to send me the file via Dropbox or as a shared Google document or something like that.